All right, colleagues, so we're looking at elasticities of demand. Basically, the elasticity, when you hear the word elasticity, just think of how responsiveness or sensitivity, okay, of quantity demanded. Responsiveness or sensitivity of quantity demanded. Okay, we'll be looking at three elasticities: price elasticity of demand, cross price elasticity of demand, and income elasticity of demand. Okay. So as I'm solving the question, I'm going to be reminding you with the concepts. All right. So here you have a demand function here. Okay. It reads Q D7 equals 5 minus 0.25 PZ plus 1.5 PW plus 0.003 M plus 3A. Now, these letters have got a meaning, they represent something, okay? QDZ is saying this is the quantity demanded for good Z, okay, colleagues? Because there's a Z here at the bottom here, so it means quantity demanded for good Z. PZ represents the price of good Z. PW represents the price of good W. M represents the income, per capita income, income for the per person. A represents advertising. Now, before I go further, colleagues, do we remember how to interpret a demand function like this? Madam Karen and Madam Mumba, do you remember how to interpret this demand function? Okay, let me interpret. Kindly mute your mic, madam. So in this demand function, this is how you interpret it. This quantity demanded is dependent on four things, okay? Quantity, or you remember? Okay, kindly just illustrate for our colleagues. Okay, let me just illustrate to make life easy. So quantity demanded for this good is dependent on four things, okay? This is the dependent variable, and then these other four are the independent variables. Okay. Quantity demanded is the dependent variable. Is dependent on the price of the good. It's also dependent on the price of the other good, good W. It's also dependent on the income of the people, and it's also dependent on advertising. So these signs here, this minus, this plus, and this plus, can illustrate the relationship between quantity demanded and each variable ceteris paribus. If we hold the other variables constant, this is what I mean. If we look at the relationship between the quantity demanded of good Z and the price of good Z, okay, if we hold other variables constant, meaning P, W, M, and A, we hold them constant, and we look at the relationship between QZ and PZ. Because of this minus sign, there is a negative relationship, meaning if the price of good Z goes up, quantity demanded of good Z goes down. Uh-huh. Is that a question? Was that a question? Okay, yes. So because of this minus sign, the relationship between QDZ and PZ is a negative relationship, holding other variables constant, meaning ignore these PWM and A. Just focus on QZ and PZ. Because of this minus sign, there is a negative relationship. If the price of good Z goes up, quantity demanded of good Z goes down. If the price of good Z goes down, quantity demanded of good Z goes up. That is the negative relationship. Any questions? Okay, if we look at the relationship between QZ and PW, have you seen there's a plus sign, plus 1.5 PW. If we hold the other variables constant, meaning ignore PZ, M, and A, and you just focus on QZ and PW, because of this plus sign, there is a positive relationship between the two variables. Meaning, if PW goes up, the quantity demanded is also going to go up. That's a positive relationship. They move in the same direction. Negative, they move in opposite directions. So if the price of good W goes down, quantity demanded of good Z goes down. Okay. Then, if you look at the relationship of QZ and M here, because of this plus sign, there is a positive relationship. Meaning if the income goes up, quantity demanded of good Z goes up. If the income goes down, quantity demanded of good Z goes down. Okay, colleagues, that's how I just wanted to give you a refresher of how to interpret these demand functions. It's very important that you're able to interpret these functions. Now, we are looking at the elasticities here. Okay, so in the question here, they've told us PZ equals 40 kwacha, PW equals 60 kwacha, M equals 30,000, and A equals 100 kwacha. Okay, so the question has told us determine the on-price elasticity of demand and state whether demand is elastic, inelastic, or unitary elastic. Okay, so price elasticity of demand, remember colleagues, this is how quantity demanded responds to changes in price. Price elasticity of demand, how quantity demanded responds to changes in price. Just hold on, colleagues. Uh-huh. Okay. Okay. Yes. Price elasticity of demand, how quantity demanded responds to changes in prices. Okay. So, the first thing you need to do with this type of questions, it's always uniform. The first thing is you need these values they've given you here. You need to put them in your demand function, okay, so that you can find the quantity demanded of the good. Always, before you even start going to these determining these elasticities, these values you need to put them into your demand function first. That's the first thing you always need to do. Okay, so if we do that, if we substitute PZ for 40, so in our demand function, you write it like this: Q dz equals 5 minus 0.25 PZ, we'll replace it with 40, plus 1.5 PW is 60, so replace it with 60, plus 0.0003. M is 30,000, so replace it with 30,000 plus 3. A is 100, you place it 100. Okay. Let's get our calculators. I've already got the answer for this, but let's just get our calculators. Tell me what value of Q you find. Tell me what value of Q you get. Has anyone found the value? Yes, Madam Momba, have you found a value? Mr. Kenny or Mr. Patrick, have you found a value? Let me know once you found a value. Remember, colleagues, managerial economics always come with a calculator and a paper. There's a lot of calculations involved, so I usually advise not to just listen in. If you listen in, you won't do yourself any favor. You're actually making things worse for yourself. At least have a paper and a pen and see if you can attempt the calculations. Mm-hmm. Has anyone found the value now? Madam Mumba, have you found the value? Mr. Kenny, have you found the value? 394. Okay, let me just check. Yes, that's correct. 394. Yes. So, colleagues, every time you're dealing with these questions, this is the first thing you need to do. Why is the first thing you need to do? Look at these formulae for the elasticities. Have you seen these Q's here? This Q, this Q, and this Q. That's where we're going to be replacing. That 394 is what we're going to replace for Q in this formula. All right. So once you found Q, okay, this is the formula for the price elasticity of demand. Okay. The partial derivative of the demand function over partial derivative of pz. What this is telling us here in simple words, in plain English, is that this demand function here, this one here, we are going to derive it with respect to pz. That's what this is telling us. We are deriving the demand function with respect to pz. Okay? Multiply by the price of goods Z over the quantity. This PZ, we already have it. They told us we already have it in the question. PZ is 40 and Q we've already calculated. So all we need to do now is just to derive this function with respect to PZ. Okay. So as I said, this is the trick that you can use. Let me write the demand function here. Q dz. We're deriving this with respect to z. So 5 minus 0 point 5 minus 0.25. Why is it failing to write there? Oops, what have I done? Okay, Q equals 5 minus 0.25 PZ plus 1.5 PW plus 0 point, yes. Mm-hmm. Is that a question? Yes, Mr. Patrick? Yes, Mr. Patrick, you can go ahead. Okay, so this is how we do the partial differentiation. Okay, we're deriving this demand function with respect to PZ, meaning if a number doesn't have a PZ, it disappears. 5 doesn't have a PZ, it goes. 1.5 doesn't have a PZ. 0.03 doesn't have a PZ. 3A doesn't have a PZ. Okay, so you're only focusing with numbers that have a PZ. And as I said, the trick here is when you're deriving, just sub just remove this pz. Okay, and this is your answer here, negative 0.25. Okay, when you derive this demand function, you find which number is the pz. Once you find that number, just remove the pz and you get your answer like this. Any questions? Any questions? Now the official way to do it, okay, is like this. This pz is to the power 1. This is the official way to do it. Pz is to the power 1. Whenever you're deriving, you multiply the exponent with the number in front of the letter. 1 times negative 0.25, you get negative 0.25. Then you subtract a 1 from the exponent. 1 minus 1, that is 0. Okay, so you mean with negative 0.25 pz to the power 0. Any number to the power 0 is the same as 1. So that's why we ignore this one and just leave our answer like that. Okay, that's how you derive. Okay, but the shortcut, as I said, just remove the letters and you get your answer. Okay, so colleagues, we found this part of our formula, partial derivative of qz over pz, and we need to multiply it with this part of the formula. So this negative 0.25, we're going to multiply it with pz. We said it is 40. In the equation they gave us, the price of goods Z is 40. Q, we calculated 394. Okay, so let us calculate what value do we get. So these workings, I already put them here. Just want to know what value we get. I believe I sent this document in the group. Yes, what answer have we got, colleagues? We are doing this tabulation here. Negative 0.25 times 40 over 394. What value do we get? Yes, Madam Momba, what value do we get? Yes, negative 0.025. Okay, then once you get your value, you get the absolute value. The reason why you get the absolute value is because due to the law of demand, because there's an inverse relationship between price and quantity demanded. So when one quantity is going up, one will be going down. So that there will always be a negative sign. Okay. So if you just if you don't get the absolute value, it just means every time your answers will be giving you inelastic demand all the time because a negative value is less than one. Okay. So to remove that effect, you need to get the absolute value of your answer, meaning ignore the negative sign. When you say absolute value, it means you ignore the sign. Okay. So when we ignore this negative sign, it is 0.025. Our price elasticity of demand is 0.025. And since it's less than 1, so it tells us demand for our good is inelastic. Meaning, when we say demand for the good is inelastic, it means quantity demanded is not sensitive or doesn't respond greatly to changes in price. Okay, so you can increase price by even 50%, but you find quantity demanded will drop by maybe 10%. Okay, you can increase price by 100%, quantity demanded might drop just by maybe even 20% because it's not responsive. Okay, so that's what inelastic demand means. Quantity demanded is not doesn't respond too much to changes in price. Okay, and as I said, examples of goods that have inelastic demand are goods that are necessities. Okay, if a good is a necessity where it's a matter of life and death, if they increase the price by a high amount, you will still need that. Remember during Corona, masks and hand sanitizer were a necessity. So if they increase the price of those goods, you still needed to buy them to survive. Even if you're, let's say, for example, you're sick of cancer, medication goes up. To live, you need to still do that, purchase that medication. So you still have to pay that price. So even though it goes up, you still need that medicine. Another reason why demand is inelastic is because some goods don't have substitutes. Okay, for example, salt. Let's make a theoretical example. There's only one salt seller here in Zambia, and we know salt hasn't got substitute. If that seller increases the price of salt by 50%, you can't substitute salt with anything else. You'll be forced to buy the salt still. Others, yeah, they might not be able to afford it, meaning they won't be having meals with salt. But those who can still afford the salt will still need to buy the salt. That's what inelastic demand means. Okay. And as a managerial economist, someone who makes decisions for a business based on the principles of economics and management, if you know the demand for your good is inelastic, to increase total revenue, would you increase the price or would you lower the price? Let me ask you that, Mr. Ken. Okay, let's say you're appointed as the managerial economist of your business and you find out the good that you're saying demand is inelastic, and then you want to increase revenue for your business. Are you going to increase the price or lower it? Mr. Patrick, Madam Mumba, if you know the good that you're selling Let's say has got no substitutes. Yeah. Yes, yes, you can increase the price because you know that even though you lose customers, there won't be a lot. You might lose few customers. All right. So to increase total revenue, you can increase the price if demand is for your good is inelastic. Please remember this because they like bringing these type of things in the questions. If demand for your good is inelastic, to increase revenue, increase the price. Most of the times, your total revenue increase. Most of the times, won't say 100% of the time. Okay. Then, if your price of elasticity, if your PED was greater than one, okay, just remember this. If your price elasticity of demand is greater than one, it means demand for your good is elastic, meaning demand is sensitive or responds greatly to changes in price. Meaning, if you increase price even by 1%, you're going to lose a lot of customers. The reasons why demand for a good can be elastic. One, there can be a lot of substitutes around there. So if you increase the price, people are going to buy other goods. They'll buy the substitutes. And two, if your good is not a necessity, it's a luxury, which people can do without. Then you increase the price. Since people can do without that good, they can stop buying. So now, as a managerial economist, you find out demand for your good is elastic. To increase total revenue, would you increase price or would you lower the price? Mr. Kenny? Mm-mm. If you increase, you're losing customers, sir. You will lose a big share. They'll buy the substitutes. But if you lower the price, you will attract more customers. Theoretically. Remember, all of this is theory. Okay. If you lower the price, let's say by 1%, you find quantity demanded increases by 30%, meaning you've got a lot of customers by just lowering the price by a small amount. So, the more customers that come in, that they'll be buying your goods, so eventually your total revenue can also go up. Okay. So, if demand is elastic, reduce price to increase total revenue. If demand is inelastic, increase price to get increase total revenue. Then there's this one which we call unit elastic. Unit elastic just means when your price elasticity of demand is equal to one. It means if you increase price by 20%, quantity demanded will drop by 20%. If you reduce price by 1%, quantity demanded will increase by 1%. Quantity demanded and price, the percent changes are the same. Okay. But theoretically, it's very hard to find goods that are unit elastic. Okay. Yes. Any questions before we now move to the cross price elasticity of demand? Okay. So remember the trick here is all these elasticities of demand is how quantity demanded is responding to something else. Price elasticity of demand, quantity demanded was responding to price. Price of the good, Cross price elasticity of demand is how quantity demanded of a good responds to changes in prices of another good. Okay? How quantity demanded of a good responds to changes in prices of another good. Okay? This is where we bring in the issue of substitutes and complementary goods. I know we all know what a substitute good is. What is a complementary good? A complementary good is a good that is used together with another good. By itself, it's of less value or useless. Think of a screen protector and a phone. The screen protector, you cannot use a screen protector. You cannot just buy a screen protector, you don't have a phone. What will you use it for? Okay? So, that's what cross price elasticity of demand determines whether a good is a substitute or complementary. So cross price elasticity of demand. These they work in the same fashion. Have you seen the formula here? Where there was PZ, we're just replacing it with PY. It's the same as the price elasticity of demand, okay? Here, let me put it like this here. Here it was Q partial derivative of QZ over PZ. Now with cross price elasticity of demand, I think I wrote the formula here. Yes. Partial derivative of QZ over partial derivative of PW. Okay. So notice the only things that are changing in this formula is the denominator here and the numerator here. So here is the partial derivative of our demand function with respect to PW multiplied by PW over Q. Now remember, colleagues, Q we've already found it. Q equals 394. PW they've already given us. PW equals, was it 40 quad? The question they told us PW equals 60. 60 quad. So we get the partial derivative. As I said, the trick here, when you look at this demand function, since we're deriving with respect to PW, if a number doesn't have a PW, it disappears. It goes. You ignore it. Okay? So this 5 doesn't have a PW. This 0.25 doesn't have a PW. M doesn't have. 0.03 doesn't have. 3 doesn't have. So you're only focusing on this number here. So as I said, when you derive, to make life easy, you just cancel this out. And have you seen our answer is 1.5 here? Okay, 1.5. Okay, that's the partial derivative. And once you find the partial derivative, you use the formula. Partial derivative of QZ over PW, 1.5 times PW 60 over Q, which is 394. 1.5 times 0.152, we get 0.228. So since our value is positive, it tells us that PW and PZ are substitute goods. Meaning, if the price of PW goes up, we come to our demand function here. Okay. Even without doing cross price elasticity of demand, if you look at our demand function here and you look at the relationship between quantity demanded and PW, just because of this positive sign, you can tell already that, okay, this is a substitute good. Because if the price of PW goes up, or if the price of good W goes up, it becomes expensive. meaning good Z is cheap. So what will happen? The quantity demanded of good Z is also going to go up because people have stopped buying good W and they're buying good Z. Okay. If the price of PW goes down, it means good W is cheaper than good Z. So people buy more of good W and they buy less of good Z, meaning quantity demanded of good Z is going to go down. Okay. So just by this positive sign here, you can already tell that these are substitute goods. Okay. But according to cross price elasticity of demand, you need to calculate. And since we've got a positive value, you can say that goods W and Z are substitutes. Goods, any questions? Goods W and Z are substitutes. If we got a negative sign, then it means they are complementary goods. Any questions? Okay, finally, calculate the income elasticity of demand and state whether good Z is a normal or inferior good. So remember the format here. Income elasticity of demand. So it's how quantity demanded responds to changes in income. All these elasticities, it's quantity demanded responding to something. Either the price of the good, the price of another good, or the income. Okay. So here, that's where we differentiate between a normal and an inferior good. A normal good is a good that when your income increases, you buy more of that good. Tea, bread, sugar, milk, butter, chicken, beef, pork, lot of normal goods out there. When your income increases, your salary increases, you buy more of these things. Okay, if your salary drops or you lose your job, you buy less of these goods. Then, an inferior good is a good when your income increases, you buy less of it. And if your income drops, you buy more of it. So, I don't want to state certain goods as inferior goods because I feel to some people it might look like an inferior good. To other people, it's a normal good. So maybe in this, I can say maybe cachasu. Okay, cachasu is an inferior good. When your income grows, you buy less cachasu and you start buying more better alcohol. You buy more C or Caso or Heineken. But if your income drops, you cannot afford the more C, Caso or Heineken, so you'll be forced to go back to the cachasu. So, income elasticity of demand. Okay, this is the formula. Derive the demand function with respect to M multiplied by M over Q. Okay, so let me get this here. We derive this demand function with respect to M. So if a number doesn't have an M, it goes. 5 doesn't have an M, 0.25 doesn't have an M, 1.5 doesn't have an M, 3 doesn't have an M. So remember, when deriving, just since we're focusing on 0.00, 0.003 m. This is the number we're focusing on. So when deriving, just get rid of this m, and your answer is 0.03. Okay. The official way, remember this is m to the power 1. 1 times 0.003, 0.003. Subtract a 1 from the exponent, 1 minus 1, that is 0. Now remember, m to the power 0 is the same as 1. Okay. But to make life easy, just rub out the letter and whatever you remain with is your answer. Okay. Now that we've got the partial derivative, we can now solve. We're going to say 0.003 multiplied by m. M, they told us, was 30,000 in the question. They gave us that information in the question. Told us m was 30,000. All right. So 30,000 divided by 394, you get 76.1. 76.1 times 0.0003, you get 0.0228. Oh, almost similar to the other one. 0.0228. So since the value is positive, we can say this is a normal good. Okay. And as I said, even without tabulating this income elasticity of demand, if you look at your demand function, if you look at the relationship between QZ and M, 0.0003 M, holding these other variables constant, there is this plus sign. This plus sign is telling us is if your income increases, you buy more of good Z. If your income drops, you buy less of good Z. Any questions, colleagues?